Right now, on this M2 MacBook, I'm running a 70 billion parameter AI model. Completely offline, zero API costs, total privacy, no cloud, no subscription, no data leaving this machine. And the responses are coming back in under 2 seconds. By the end of this video, you'll know exactly how to set this up yourself, which models actually perform well locally, and why this might be the smartest technical decision you make this year. Most people think you need a $10,000 GPU rig or a cloud subscription to run serious AI models. That was true 2 years ago. It's not true anymore. Apple Silicon, the same chip in your MacBook, has unified memory that lets you run models that would choke a dedicated gaming PC. And almost nobody's taking advantage of it. I've been running local models for my entire AI automation stack for months now, and I'm going to walk you through everything I've learned, what works, what doesn't, and the exact setup. I'd recommend, whether you're on an M1 MacBook Air or an M4 Max Mac Studio. Before we touch any software, let's talk about why you'd even want to do this. There are 4 real reasons, and none of them are hypothetical. First, privacy. When you send a prompt to ChatGPT or Claude's API, that data leaves your machine. For most personal use, that's fine, but if you're working with client data, financial records, medical notes, or anything covered by privacy regulations like PIPEDA here in Canada, local inference means your data never touches someone else's server, period. Second, costs. I run an AI automation business called Local AI Hub, and API costs add up fast. Every call to GPT-4 or Claude costs tokens. When I'm doing bulk content analysis, running embeddings across thousands of documents, or testing prompt variations, local models save real money, not theoretical savings. Actual dollars that stay in the business. Third, speed and availability. No rate limits, no API outages, no latency from round tripping to a data center. When I'm iterating on a prompt or running an agent loop that makes dozens of calls, local inference is often faster because there's zero network overhead. Fourth, learning. You understand AI at a fundamentally deeper level when you're loading models, adjusting parameters, and seeing how quantization affects output quality. This isn't abstract. It's hands-on knowledge that makes you better at using cloud AI too. Here's what makes Macs uniquely good at this, and it comes down to one architectural decision Apple made: unified memory. On a traditional PC, your CPU has its own RAM and your GPU has its own VRAM. Running a large AI model means fitting it into GPU VRAM, which is typically 8 to 24 gigabytes on consumer cards. A 70 billion parameter model needs roughly 40 gigs of memory at 4-bit quantization. That won't fit on most desktop GPUs. Apple Silicon doesn't have this bottleneck. The CPU, GPU, and neural engine all share the same pool of memory. An M2 MacBook Pro with 32 gigs of unified memory can load a model that will require a $1,600 NVIDIA GPU on the PC side. An M4 Max with 128 gigs of unified memory can run models that most people think require enterprise hardware. Now there's a trade-off. Apple's GPU isn't as fast per core as an NVIDIA A100 or H100, so generation speed and tokens per second will be lower than a high-end dedicated GPU. But for most practical uses, you're getting 20 to 40 tokens per second. On recent Apple Silicon, which is absolutely fast enough for real work, you won't notice the difference in a conversation. You'll notice it if you're trying to process 10,000 documents in parallels. And for that, you'd use cloud compute. There are 3 main ways to run AI models locally on a Mac, and each one serves a different purpose. I use all 3 depending on what I'm doing. Number 1, Ollama. This is where most people should start. Ollama is a single command line tool that downloads, manages, and runs models with almost zero configuration. You install it, type Ollama, run Llama 3.1 in your terminal, and you're having a conversation with a local AI in under 2 minutes. It handles quantization, memory management, and even exposes an API endpoint at localhost that's compatible with the OpenAI API format. That last part is huge. It means any tool or script built for OpenAI's API can point at your local Ollama instance instead. Number 2, MLX. This is Apple's own machine learning framework built specifically for Apple Silicon. If Ollama is the easy button, MLX is the performance button. It squeezes more speed out of the hardware because it's optimized at the meta level for unified memory. The MLX community on Hugging Face has hundreds of pre-converted models ready to download. You install the MLX LM Python package, and you can load and run models in a few lines of code. I use MLX when I'm building custom pipelines, things like my content analysis system where I need programmatic control over generation parameters. Number 3, lmstudio. This is a desktop app with a graphical interface. You browse models, click download, and chat through a clean UI. It also runs a local API server. If you're not comfortable in the terminal, lmstudio is genuinely excellent. It's not a toy. Serious developers use it for testing and comparison. This is where most guides fall apart. They list 50 models and leave you more confused than when you started. I'm going to keep this simple based on what I've actually tested and used in production. For general conversation and writing, Llama 3.18b is the sweet spot. It runs fast on any Apple Silicon Mac, even the base M1 with 8 gigs of RAM. The quality is surprisingly good for an 8 billion parameter model. If you have 32 gigs or more, step up to Llama 3.170b. The jump in reasoning quality is significant. For coding assistance, Qwen 2.5 Coder 32b is exceptional. I've used it for Python scripting in my automation pipeline, and it holds its own against cloud models for straightforward coding tasks. DeepSeek Coder V2 is another strong option. Both run well on 32 gig machines at Q4 quantization. For lightweight fast tasks, classification, extraction, reformatting, Phi-3 Mini, or Gemma 2.2b, and these are tiny models that respond almost instantly. I use them for things like sorting incoming content into categories or extracting structured data from messy text. They're not going to write you an essay, but for focus tasks, they're remarkably capable. For embeddings and RAG, Nomic Embed, or MXBI embed large through Ollama. These are embedding models that convert text into vectors for similarity search. If you're building any kind of knowledge base or document search system locally, you need these. One important note on quantization. When you see Q4 KKM or Q5 Phi KES next to a model name, that's the quantization level, how much the model has been compressed. Q4 means 4-bit, which cuts the model size roughly in half compared to full precision. For most use cases, Q4 gives you 90 to 95% of the full model's quality at a fraction of the memory cost. Don't obsess over getting the highest quantization unless you have memory to spare. Let me show you how I actually use this day to day, because the real value isn't just chatting with a local model. It's integrating local AI into your workflow. I run Ollama as a background service on my Mac. It starts automatically and listens on port 11434. Any script I write can hit that endpoint like it's hitting the OpenAI API. I have a simple routing layer in my automation stack. Quick classification tasks go to the local Phi-3 model. Embedding tasks go to local Nomic Embed, and complex reasoning still goes to Claude's API, because honestly, for strategy and nuanced content, cloud models are still ahead. But roughly 60% of my AI calls now run locally. For document analysis, I built a local RAG pipeline using Ollama embeddings and simple vector store. I can drop a PDF into a folder. It gets chunked, embedded locally and indexed. And then I query it with natural language and get answers grounded in the actual document. Now, all running on my MacBook, no data leaving the machine. For client work where confidentiality matters, this is essential. Here's my practical advice if you're just getting started. Install Ollama today, pull Llama 3.18b, and use it for 1 week. Replace one task you currently use ChatGPT for, maybe drafting emails, maybe summarizing meeting notes, maybe brainstorming. Just one task. You'll immediately feel the difference. No login, no subscription, instant responses. Complete privacy. Once that clicks, you'll naturally start finding more uses for it. Before I wrap up, let me save you from the 3 mistakes I see most often. Mistake 1, trying to run a model that's too large for your memory. If you have 16 gigs of RAM, don't try to load a 70B model. Your Mac will start swapping to disk, inference will slow to a crawl, and you'll think local AI is broken. It's not, you just overloaded it. Stick to models that fit comfortably in about 80% of your available memory. Mistake 2, expecting local models to match GPT-4 or Claude on every task. They won't. Local models are phenomenal for focused, well-defined tasks. They struggle with complex, multi-step reasoning, nuanced writing, and tasks that require broad world knowledge. Use local for speed and privacy. Use cloud for depth and complexity. The smartest approach is hybrid. Mistake 3, not using the API server. Chatting in the terminal is a good demo, but the real power is programmatic access. Ollama's API server lets you build scripts, automations, and tools on top of local inference. That's where you go from cool experiment to actual productivity tool. That's the complete picture. They're from zero to running AI locally on your Mac. If you found this useful, the next video I'm working on covers building a full local RAG pipeline step by step. And your own private AI knowledge base. What topic should I cover next? Drop it in the comments. And if you're running models locally already, I want to hear your setup. What model, what hardware, what you're using it for. I'll see you in the next one.